All right, guys, I'm just going to help you review how to draw those Lewis dot diagrams that we worked on in class. So the general steps that I'm going to be using are I'm going to add up all the valence electrons of every atom involved in the molecule. I'm going to determine what my central atom is, and then the other ones are going to surround it with some exceptions that we'll go over where we have some larger chains of atoms. Then we're going to start with all single bonds. That's the most important thing that you'll hear me keep saying. And remember that each single bond is 2 electrons. And then we're going to start with the outer atoms, fill them up to get a complete octet. With hydrogen, we'll discuss, and then we'll go from there. So let me just go over in the examples that I had for you on the sheet. I'm just going to pick out a couple that kind of focus in on steps 1 through 4 first. So one little thing just to keep in mind is how we're getting valence electrons. We know that group 1 is 1, 2. Anything that's in group 13 is going to have our 3 valence electrons and so forth. So that's where I'm going to get all these numbers from based on what column they are on the periodic table. All right, so for this here, if I add up for hydrogen fluoride, add up my valence electrons, I have 1 from hydrogen and 7 from fluorine, so I'm going to have 8 valence electrons to work with. Now this is just 2 atoms, so I'm going to place them next to each other. I'm going to always start with a single bond between them. So that single bond represents 2 electrons. So I'm going to take 2 out of my total. So I just have 6. So I'm going to look at both of these. Hydrogen will not get any additional lone pairs on it. It completes its first shell when it has those 2 in the bond. So it is stable. With this one bond, you will never put extra dots or anything more than a single bond to hydrogen. So those 6 electrons then are going to go on fluorine, which makes sense because when I put those onto fluorine, okay, not that you would normally draw these circles around it, but you'll see that fluorine has the 2 in the bonded pair, and then 2, and then 4, 6, 8, including the lone pair. So it gets to its complete octet, so that's stable. Hydrogen has its 2 in the bond, so I can leave that as is. And again, you wouldn't see the circles on there normally. If we have something such as our C2H2F2, so some similar ones than before, but here we're going to have carbon in the center. So when I go to add these up, carbon is 4. I have 2 hydrogens that are 1 each. I have 2 fluorines that are 7 each. Okay, so for this part here, we're going to add those up where I have 2 and 4 is 6 and 14 is 20. Okay, I'm going to start with carbon here in the center. Usually carbon is a central atom. And I'm going to place my hydrogens and fluorines around the carbon. Okay, and we're just looking at this 2-dimensionally right now. We'll get into shapes later on. I'm going to start with single bonds between all of them. So that's 2, 4, 6, 8. So I'm going to subtract 8 out of there. So I'm left with 12 electrons. Same thing as before. Those hydrogens get the single bond. They're full. So if I look at this first fluorine, I see I have the 2 in the bond, which means I need 6 more, which should make sense. This fluorine is going to need 6 to get to 8. And then my other fluorine is also going to then need 6 to get to 8. And that's my 12 remaining electrons. So if I check, fluorine has 8 electrons around it. The carbon also has 8. Always check the center one around it. And so everything has a satisfied octet, including the hydrogens, which have their 2. If I also check my total, always make sure you actually drew the correct total. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that one's done. Okay, so those are 2 examples where you have the exact amount of electrons that you need to give everything a complete octet. So let's deal with some in step 5 up here that I have, that when you do that and you fill up the outer atoms, well, what do you do when you still have extra electrons? Okay, and there are things that still don't have a complete octet. So let's go ahead and take a look at, in that case, water. Okay, so if we look at water, hydrogens, they each have 1, plus my 6 from oxygen, so that gives me 8 valence electrons to work with. Hydrogen is never going to be central atom, so that means oxygen is. And I'm going to first draw this how most students are going to start with it, and we'll talk about it in just a second. And then I'm going to have the hydrogens on the outside. I'm going to draw my single bonds between the hydrogens and the oxygen in the center. That was 2, 4 electrons, so I have 4 electrons left. Well, I look on the outside. Those hydrogens are complete with their bond. So those 4 electrons cannot go on the outer atoms. So that's when you want to look at the central atom. If I look, oxygen only has 4 in the bond. So that means it needs these 4 electrons to go on the oxygen. So most students would start, drawing it like that, which makes sense. What we are going to find though is those lone pairs repel those bonded hydrogens and their electrons more. So when we actually look at the shape, it's going to take on a bent shape. And I just want you to get right away in the habit, especially with water, of drawing it bent. So our structure is going to look more like this. So those lone pairs are going to kind of take up space up above the hydrogens there. Okay, another example of that when we have extra electrons after we distribute them to the outer electrons is PBr3. So with this one, phosphorus, so phosphorus tribromide, phosphorus has 5. Okay, my 3 bromines, they each have 7, so that's 21, and 5 is 26. Okay, I'm going to start with phosphorus in the middle. I'm going to start with my bromines around it. Okay, I'm going to start with single bonds between them. Okay, again, always starting with single bonds. Okay, that's 2, 4, 6. So I'm going to subtract out 6 electrons, and I have 20 left. Okay, I'm going to look on the outer ones first, so always start with the outer ones. So this bromine has 2, it needs 6 more. So if I look, this should make sense to me in the sense of this needs 6, 6, and 6. So 6, 12, 18. So I'm going to go ahead and put 18 of those 20 electrons onto the bromines. I'm going to subtract out my 18, and I have 2 left. So now that my bromines are all filled up, I have these 2 extra electrons. I see that phosphorus in the middle only has, if I draw a circle around it, only has 2, 4, 6. It needs to get to its complete octet. So those 2 electrons are going to be placed on the phosphorus there. Okay, so water and this phosphorus tribromide are 2 examples of we had extra electrons and we're placing it on the center atom first before we do anything else. And keep in mind, I said this to you, this is just like a little kind of organizational method that you might want to use when you're starting these. And then as you get faster and faster, you may not need these. And that's okay. I'm not going to be something I'm checking for extra work. All right, there's one other scenario in our directions up at the top where, okay, you filled up the outer atoms, you're checking all your atoms, but something doesn't have enough electrons, such as the center one. What do we do then? This is the only time that we're going to be thinking about moving electrons and making a double or possibly a triple bond. So if we take a look at N2, so this is a very common one that has a multiple bond that you have to know. I have 2 nitrogens, so 2 times the 5 that each nitrogen's valence electrons gives me 10. I'm going to start with the 2 nitrogen next to each other. Okay, always keep those 10 paired together. So I'm not going to put 5 and 5 on here. I'm going to have to go with, I had to start with my single bond. Start with my single bond, so that's going to be my 2. So I only have 8. So in this case, I'm going to have my 2, 4, 6, 8. Okay, I've used up all my electrons. So again, if I check 2, 4, 6, 8, 10. Okay, 10 electrons there, that's all I have. But when I look, neither nitrogen has 8 around them. They only have 6 each, the 2 in the bond and the 4 that are in the lone pairs. So this is the only time where you're going to start to think about, okay, now we need to share extra electrons to get them to their complete octet. So this is where using a pencil is very helpful because I'm going to take, and I'm always going to do this in pairs, these 2 electrons together, and I'm going to move them to the center. Okay, that's great for the nitrogen on the right. I just got it up to 8 by sharing the electrons from the one on the left. The left one still has those 2 electrons. It can still access them. It's still going to help complete its octet, but now it's sharing it with the other one. But again, now this guy over on the left still doesn't have enough, so I'm going to take 2 electrons from my other atom, move those into the middle, and if I check, I still have 10 total. I have 2, 4, 6, 8, 10, but now if I check each of them, they each have those 8 electrons around each of them to give them that stable octet, so I know that structure is correct in that case. Okay, if I look at like CO2 over here, so carbon dioxide, carbon's going to be in the center. So carbon has 4 valence electrons. Each oxygen has 6. So 2 times 6 gives me my 12, and 4 is 16. So I'm going to have carbon in the center. I'm going to put my oxygens on the outside. Start with single bonds, as always. So that's 2, 4. Okay, I have 12 left. So I'm going to put 6 on my outer oxygen. Okay, I'm going to put 6 on my other outer oxygen, which means that I used up all my electrons again. And again, I'm following the same step. I'm always going to start with the outer ones and then see where I'm at. So now that I'm at 0, if I look, this is a problem because carbon in the center only has 4 around it. It doesn't have a complete octet, so this can't be the structure for carbon dioxide. So that's when I'm going to use my oxygens, which do have 8 around them, and I'm going to start sharing them with carbon. So in this case, I'm going to take 2 from the oxygen on my right, place them in the middle. Okay, so now this carbon is now up to 6. My oxygen still has 8 around it, so it still has its complete octet. And then I'm going to do the same thing on my other side. share those 2 electrons. So now this carbon now actually has 8 electrons around it within the double bonds on both sides, and each oxygen also has the 8. One little thing is this will actually keep this linear structure across. You can see there's no lone pairs on carbon, which makes the structure much different than the water molecule. Okay, so those are just some different examples that we did in class so that you can see them again, and hopefully ask me further questions in class if you need them.